Hello, and welcome to episode 11 of TGIK. Last time I had some microphone problems, so if folks could let me know if you can hear me fine. Hopefully, I have those resolved, and we can go ahead and get started. For those who don't know me, I should probably introduce myself. I'm Joe Beda. I'm one of the founders and the CTO of Heptio. I also was one of the founders of the Kubernetes project, and so the goal of TGIK is to have me explore some new stuff and what's going on with Kubernetes. Look at it from a sort of like, hey, let's just play around and see what we can figure out point of view. The truth of the matter is that even though I'm heavily involved every day in what's going on with Kubernetes, there's so much going on that a lot of times I don't even know. And so this ends up being a great way for me to explore things that I'm not as familiar with as I should be. So yeah, if you folks could let me know if you can hear me and see me, that would be great. I think I'm streaming right, but like it's always so weird talking into the void. With that, let's see. I want to see if anybody's watching. Let's see, is it working? There we go. Okay, cool. All right, rolling and on Angel, Andres, Steve. Awesome. Okay, good. Video and sound are good. Well, hopefully it'll stay that way. So today I'm drinking what we call around here low carb beer, otherwise known as whiskey, because Alex drank all the beer, and then he drank all my whiskey too. And there wasn't much left, just to be honest. I don't want to out him too much. And so I had to steal some whiskey from somebody else. But there's a good chance that they may run down and grab new beer. So that's my beverage of choice today. So we're going ahead and getting started. So the plan today, and I'm also wearing my Nuke the Valley shirt, which is there's a history to this. It's ironic. I don't literally want to nuke the valley, but I do think that we have to find ways to have technology reach beyond the valley. And so part of being up here in Seattle is in some ways we're sort of valley extended, sort of a suburb, but I think in other ways we have our own way of viewing stuff, and I think it's a good thing. So we need to see more of that, more folks around the country, around the world, doing interesting stuff. So today we're going to be looking at upgrading Kubernetes using kubeadm. Now there are, and this is one of the strengths and weaknesses of Kubernetes, there's approximately a million different ways to install Kubernetes. There's different installers, there's different hosted services, and across all of these things, they have their own ways of upgrading or not upgrading and how they support those. Now, we started the kubeadm or kubeadm project a little while ago as a way to, it doesn't solve the entire install story, but once you have sort of a set of machines, once you've provisioned machines, get your container runtime on there, whether that be Docker or what have you, kubeadm is a good way to sort of bootstrap a cluster from that. And it ends up being, when you're using the simplest mode, it ends up being a single command to actually get a Kubernetes cluster up and running once you have a set of machines. There's other projects that are working on finding commonalities and building a tool set on that provisioning layer. But we found that by separating these things into some cleaner layers, we can find some more commonality and actually help to reduce the amount of overlap between the approximately 1 million ways of installing Kubernetes. So what I'm going to be doing here is going to be really working to look at this. These guys went down, and I now have real beer instead of low carb beer. Thank you very much, Fabio. So Fabio was the one who handed this to me, so if you start stuff with kubeadm, up until now there had been ways to upgrade, but it was very manual. With this, there's now and Lucas. I'm not going to try and pronounce Lucas's last name, but he's been a contributor maintainer in Kubernetes for a while. He's in Finland, I believe. He's been working hard on this stuff, and so a lot of this really comes down to him, but there's been a lot of folks that have been looking at it and testing it. So we're going to go through the upgrade process. It's a lot more automatic now than it was before. There's some gotchas, and I'll talk through some of those gotchas. If you guys have questions about what's going on, let me know. One of the things that I think we have time to do is to go through some of the spew on a sort of line-by-line basis and really talk about what's happening as we go through it. So that's my plan today. Now let's go ahead and let me switch to the screen here. And so the first thing is that there is this web page, and let me see if I can, I'll put this in the comments, but I'll also put it in, does that come through when I post it? I think. No? Oh man, I don't know if that, I think it doesn't, okay, it doesn't show up on the video when I post a link, but it does show up in the chat window, and then I'll post this in the video notes at the end also. This is a guide on upgrading this stuff, and so we're gonna roughly go through what's going on here. So this is a good place to work with. And George Castro, who does community management type of stuff for Kubernetes, is a Heptio guy, is also working on a blog post that leads through some of this stuff also, and there's some overlap with what I'm going to be talking about with this page and what George is doing. But hopefully seeing somebody sort of go through this and a few of the gotchas will help to really figure out what's happening and help people be successful here. So the one thing you do want to do is there are release notes. And the release notes are huge. It's actually a big effort to pull together these release notes. There's a lot going on. A lot of this stuff is, we try and call out any place when it's like stuff you should know or things that you really want to actually understand before you upgrade. So we try and call out some of the sort of biggest things that you're going to want to know about. So I'm going to go through, let's just go through all the items one by one on the before upgrading section here, the release notes. There's more to the release notes than I can really go through right now, but we're going to go through this stuff one by one. So the first thing, and this bit George in the butt, is that the Cubelet now fails when you have swap enabled on a node. For those who are not Linux experts, what happens, and this goes back to sort of the history of time for how operating systems works, is that if you don't have enough RAM in a machine, then there's all these virtual memory systems that essentially throw away, like they write memory to disk, to long-term storage, and then they can overcommit the amount of memory and then load that back in. This is not something that is well supported in a production environment. It turns out that if you get to the point where you're swapping, your performance pretty much goes to nothing, and it's something that will probably lead to results that are unexpected. And so in some ways it's more problematic than it is. So there is a flag here to be able to do this. I think if you still need it, that you can give to the Cubelet. This is going to be a painful thing for some folks because I think they probably are going to upgrade and not realize that they need to change this. There's an issue, and it's not linked from here, and it probably should be. I mean, it may be. Let's see. Yeah. So if you look through the if you look through the issue here, you can see that there's a lot of discussion on this, and there's a whole bunch of stuff that you can go and look through to actually see what happens. I believe, I don't know if the Cubelet supports it. I'll have to look, but I do know that with some systems you can turn on swap on a sort of container by container basis. So it essentially turns it into a whole machine type of thing to a container by container type of thing. So let's go through. So that's going to be a big gotcha for some folks. And Roland's saying that VM.swappiness in syscontrol is another thing that is a similar type of tunable. Let me go through, and I lost my thing in the release notes here, so I gotta play with this, and if I do that, does that take me there? No. There we go. Okay. So that's the biggest gotcha. I think I mentioned this before. There's some APIs are getting moved around and renamed, and some defaults in those APIs are being okay. So, well, actually, no. This one's about autoscaling API, which is the horizontal pod autoscaler, is being upgraded from alpha to beta. Now, we did have a discussion. This is something that I'm on the hook for talking about. Alpha, beta, and GA mean some very different things to Kubernetes, and it's I think, and there's different aspects of sort of what does it really mean to be beta, and and I think that Kubernetes is very conservative when it applies these labels. And so alpha, it means that, don't expect stability necessarily with this feature. Don't expect that the feature will even ship, right? It may be pulled because we may discover that it's not at the right level, it's not the right feature. We're thinking about the problem altogether wrong. And the interfaces themselves may shift dramatically as a feature moves from alpha to beta to GA. Once something gets to beta, we've had features that have been in beta for a long time. Things like deployments are technically in beta. But once something makes it to beta, there's generally, it's actually pretty stable. It probably won't take your cluster down. People have been usually using it for a while. There's a commitment that that feature in some form will actually ship. And so there may be some tweaking of the interfaces or the concepts or the defaults. But something in that vein, something that solves that problem will eventually make its way out. And then, and the API itself, the way that you interact with that feature, that may change also, but we're going to try and keep that minimal, right? We're going to try and make sure that we don't change things arbitrarily, because we do realize that people do start taking advantage of and betting on beta features. GKE, for example, by default with a production cluster, and there's no upgrade support for alpha features also. So if you use an alpha feature and the next time you do an upgrade, you may find that alpha feature, capabilities or stuff that you built using that alpha feature no longer works. So GKE, for example, for production GKE clusters doesn't enable alpha features just because it's not at the level where it can be supported across upgrades. You can start a cluster in GKE with alpha features turned on. If you do that, then I believe there's a time limit. After a certain time, that cluster will automatically be torn down. So it's really trying to get this idea across that these things are not ready for prime time yet. But and I'm making this a little bit bigger for folks. So we were right here. But when things are in beta, it's a pretty big commitment at that point. And so I think a lot of times what we call beta in Kubernetes, a lot of folks might actually call GA, depending. It's kind of maybe that's a Googleism, I don't know, maybe. So again, another sort of V1 Alpha 1 to V1 Beta 1 for the custom metrics APIs. And there's some renaming that actually goes along with that. So that's part of that. Hey, we're going to try and get some API changes in as we move to beta, because we're going to be much more careful after that. Let's see, auditing. So there's now flags in the API server to actually turn on auditing, and that ends up being turned on by default. You can specify a file, and so there's advanced audit is a thing that you can do. Third-party resources are removed. So this is a big gotcha. They were deprecated. They were never a GA feature, and so they ended up moving forward in the form of custom resource definitions. And so this is one of those examples of where the feature itself is moving forward in some way, but it's moving forward in a substantially different form. And so as part of this, there was one release, 1.7, where TPRs and CRDs could coexist. But now with 1.8, they are removed. And so during that 1.7 cycle is the time to actually adapt and move things forward. So more replication flags that were deprecated were removed. And so we deprecate stuff and we take some time. It's like change for deprecating stuff is kind of glacial. It can be frustrating when you're working on Kubernetes that it takes so long to be able to sort of clear the books and move on. But it's a commitment to be able to, have some stability as people use the system to not deprecate things willy-nilly. So like the API server flag in the kubelet has been replaced with a kubeconfig file. Stateful sets, which I believe are in alpha. There's a change to a annotation there. Annotations are not part of the API contract, but a lot of people view them as such. And so we're really, we're probably more careful than we need to be around annotations. Cron job has made it to beta. And so that's actually a big deal. It's been a long time coming. So this is a really interesting thing. So that's great. That's something we should play with that at some point. That'd be fun to play with. I haven't actually had a chance to sit down and really use it. And then scheduled jobs. So this is, again, you see a rename as you do it. Is that like this sort of scheduled job thing has been moved to cron job. So as we move to beta, that's when we start getting really careful about naming. So like stateful sets were originally called pet sets. But it was too cutesy of a name, so that got moved to stateful sets as they moved forward. And then the the alpha APIs for these API groups have been removed. And then and then there's some changes in RBAC where the system node role is no longer automatically granted to the system nodes group in new clusters. So node is actually pretty wide. And this is part of the change of moving towards the node authorizer. And so the node authorizer is a way that when the roles for nodes start talking to the cluster, it's a sort of more specialized authorization mechanism than we can do with RBAC. And so this has started moving towards that more secure way of having nodes actually integrate with it. Now, it turns out that if you're running a kubeadm cluster, you don't have to worry about that stuff. This is probably the only gotcha here if you're running a kubeadmin cluster, assuming that like you're not sort of deep into TPRs. This is probably another big gotcha that you want to be careful about. So yeah, any last questions before we start getting down in the nitty gritty? I'll go ahead and take a sip of my beer. Thank you guys. All right, so let's go ahead and get started here. What we have is I have a Kubernetes cluster. This is a small cluster with 2 worker nodes and a master node that I started using the Kubernetes Quick Start by Heptio on AWS. So Gregory's, what's my favorite change in 1.8? That's a good question. I think the biggest thing that I get excited about these days is not features, right? I think like in my mind, I want to get Kubernetes to a point where it's done. And this is part of that commitment of making this stuff be a friendly platform for people to build on longer term. And so I get more excited as we see extensibility mechanisms make their way forward, because every time we introduce an extensibility mechanism, it does a couple of things. Number one is that it gives us a plausible way to say no when people want to add new features to Kubernetes, which means that over time, Kubernetes itself becomes more stable, which is a good thing. And then the other thing that I get excited about with extensibility mechanisms is it lets people play around and do things that they never would have necessarily tried if they had to build it into Kubernetes proper. It gives them a chance to experiment and actually try new things in some really wacky ways. And so that's actually really, really exciting also. Okay, Roland says, what happens to the kubeadmin tokens and its TTL need to join nodes when upgrading from 1.7 to 1.8? So if you have a kubeadmin token as you do the upgrade, that will continue to work, so you don't have to change it. And those tokens will be modified to make sure that everything continues as before. In a future version of kubeadmin, and I don't think we didn't do it in 1.8, but in a future version, when you do a kubeadmin init, it will automatically set new tokens to expire in 24 hours. And the reason being there is that the token is in some ways a really powerful thing. We want to make sure that those powerful things that are easy to leak don't exist forever. And so we made a change to actually sort of narrow that down. You can still have them be unlimited. So if you want to take one of these tokens and actually add it to some sort of automation as you automatically scale the cluster up and down, totally cool. You can still do that. but by default that token won't be around forever. And then the other thing is that let's see, there's couple of changes. Is that the way that those tokens authorize, instead of being part of the system bootstrappers group explicitly, they're part of the systems bootstrapper group, and then there's a kubeadmin specific thing. And so there's a little bit of sort of RBAC jiggery to actually make that work. And you can also specify other groups that you want those tokens to be part of. I'll go through that and we'll look at that. And I just made a change to make that easier to use, because there was, and that'll probably make it out in 181, because there was some sort of non-obvious behavior when it came to generating new tokens, and we'll go through that. And then Suresh says, is Kubernetes and Kubernetes going to happen next version? I mean, all the control plane, I assume, components will be in a pod as well. So that is definitely, to some degree, that's already happening. And so people generally call this self-hosting, where Kubernetes is running on top of Kubernetes. The current way that things work with kubeadmin is it uses this feature, and let me explore this a little bit. And Pat, I see your question about HA. We'll go ahead and get to that also. So one of the things that I can do here is, with our things, is I'm going to actually SSH into the master. And so this is the master on a kubeadmin cluster. And let me just decode this thing a little bit here. We run these things in a sort of private VPC in Amazon. And so this is a bastion host that you sort of jump through. And so this proxy command thing here says first SSH here, and then like netcat to the eventual destination. And so that is some sort of advanced SSH magic going on there. I think we've covered that in a previous episode. You don't have to worry about it. You can just copy and paste it when you use the Heptio quick start. So if we go and if we look at etc Kubernetes manifest, cd etc Kubernetes manifest. So if we look here, there's a bunch of YAML files, and these are things like the Kube API server. You see a whole bunch. So this is essentially the thing that causes the Kube API server to run. And this looks like a pod. I mean, look at that. It says pod, the whole thing. That's pretty cool. But it turns out that this is actually, everything in this directory is special. It gets interpreted by the kubelet directly. And so this is not going through the rest of the Kubernetes machinery. The kubelet monitors this directory, picks up YAML files, and make these pods run without talking to anybody else. And so this is a special mode of the kubelet. I think sometimes folks call this sort of a free-range kubelet. So you can actually use the kubelet to run pods without running an API server. Now there's some limited features, like you don't get secrets, and and the types of volumes that'll work can be limited also. But it's a really cool thing, and that's how we run the control plane components right now. Now there is, and we've been sort of experimenting with it, but at some point we're going to move to something which is more of a true self-hosting. And to do that, what's going to be happening is that and when we actually go through it, I'll show you this is. If I do kube control get pods namespace equals kube system, what you see here is that there's the API server. The pod name ends up actually pulling in the it generates. This becomes sort of a read-only pod from the Kubernetes API, where it essentially takes these things that are run by files and sort of surfaces those up so that you can see them and inspect them. But you can't really control and manage them this way because they're managed with those files. And so this is sometimes called a static pod. What we're going to be looking at in the future, and I think there might be alpha support right now in kubeadmin, is to be able to have these things be self-hosted in a more fuller way, which means that the kubelet is actually, instead of looking at these files to run stuff, it's actually talking to the API server, and the API server is telling it to run the API server, right? Which is really confusing. It kind of bakes your noodle when you think about it. That works best with a couple of other features. HA, which helps you with, if one API server fails, we can start up another API server and they can each keep each other running. Same thing for the scheduler and the controller manager. So once you're in an HA situation, then they can actually help keep things running. And so that becomes something that really helps when you do this full self-hosting. And then the other thing is that you need, Well, Roland says, so let's see. So, okay. So, and then the other thing that you need as you do this is what's called checkpointing in the kubelet. And so what you have is, let's say that you turn off all the lights in your data center or you shut down all your VMs and then you start them back up. Well, the kubelets come up and they don't have an API server to talk to. And so they don't know what they should be running because everything went dark, right? So it's sort of like a cold boot versus a repair type of scenario. And that's sort of like full cold reboot, like what happens if everything fails at once. That's where checkpointing comes in. And what that means is that for a certain set of pods, we set up the kubelet so that it automatically knows to start the stuff that it was running before when it actually goes ahead and reboots. And so that helps to have things sort of like self-bootstrap again after a failure. And then HA is planned, Pat. That is something that we're looking at. There's a bunch of hairy questions there around how do you, like if I go and if I look at Etsy Kubernetes, I think it's PKI, right? There's a whole bunch of stuff that's sitting on disk that is important for being able to run the cluster from a sort of crypto point of view, and making sure that we synchronize this across all the HA instances is like one of those problems that we have to solve. The other problem that you need to solve is that currently, when running HA, there's this assumption that when, say, the kubelet talks to the API server, it only knows one endpoint to talk to, and so you really need a load balancer in that situation to be able to talk to that. The kubelet itself, or essentially the Go client library for Kubernetes, doesn't really know how to view a set of API servers as being peers and pick one and sort of update that set over time. And so there's some issues in terms of both addressability and distribution of that stuff. And what you'll find is that a lot of the sort of install toolkits that do support HA, they end up copying this stuff around. It can be a little dangerous, but it's doable, right? I think COPS throws this stuff up on S3, for example, and then uses that as a meet-me point. And then there's also that issue of how do you actually sort of go ahead and have these things find the API server. You can either use sort of a cloud load balancer to do that, which is obviously not something that fits with the kubeadm model because somebody has to allocate and start that thing. Or there's other systems out there that will do things like use a gossip protocol to find things and then rewrite the host file on all your machines, which is a little bit hokey also. So we're working through a bunch of those issues. The next concrete step with HA is going to be something more along the lines of how do I take it? I think this is going to be more of a guide, and I think Tim St. Clair might be working on it here at Heptio, but this is going to be more of a guide of how do I take a kubeadmin cluster and upgrade it to HA. There's going to be some manual steps. You're going to copy these files around, that type of thing, but at least you'll be able to do it. And then we can work on automating that over time. So that's some long-winded answers there, but it's good information. It's good information. Okay, so let's go through and we're going to upgrade this guy. So what I can do right now is I can do kube control get nodes, and I'm logged into the master right now. And you can see that the version of all these nodes is 1.6. It turns out that's the version of the kubelet, right? If I want to get the version of the API server, I can go ahead and I can do kube control version, and this is really ugly. I don't know, like we should probably at some point make this prettier, but that's probably a breaking change. The version here is git version, which is it's essentially, this is a dump of a Go structure, but the git version ends up being sort of like the version that the thing was tagged at, and so that's the thing that you want to pay attention to. So while it says static pod, so that means that they cannot be auto-scaled. Is that a good idea for infra pods? It is what it is. I mean, at some point you have infrastructure that has to be sort of bedrock, and that bedrock infrastructure, has some level of manual configuration, I think. And so you'll find that in any infrastructure system, there is something that has a certain amount of sort of manual touch to it. And then and the idea is that you want to minimize that, understand it, and constrain it as much as possible. And so in a lot of people's setups, like the DNS servers end up being bedrock because that's how things find other things, right? And so your DNS servers ends up being special. Yeah. Oh, okay. So Eli says we can do short. There we go. Oh, look at that. Yeah, that's what you really want. And then there's YAML. So there's all sorts of different. Oh, wait, does that work? Version. No, I don't think YAML works. Or no. Oh, wow. It's. Okay, so it's -- output. It doesn't have the same alias as everything else. So that'll actually get you there too. So this actually is just talking when it says server version. This is talking about the API server. The YAML is only 1.8. So SIG cluster lifecycle, the one to watch for all the kubeadmin features updates. Yeah, that's where we meet and discuss a lot of that stuff. So if you want to get involved, if you want to sort of watch how the sausage gets made, SIG cluster lifecycle is the place to go. And if you can't find the pages, there's a SIG list in the community repo that lists all these things, that all the SIGs and where they meet and how to talk to people, that type of thing. Okay, if you want to figure out, so this is the API server. If you want to figure out sort of like the version of, like, say, the controller manager, it turns out that it's really hard to do. It's harder than it should be. So I can do this, and that lists the single pod, YAML, and then I can look at this, and what you'll see here is we can look at the image that you're using for the control manager there. And then you'll also see that it goes through and actually resolves that to a SHA, so that if that thing gets relabeled, you're going to be stable. This assumes that you're actually using like the static pod method. If you're using something else to be able to sort of manage, if you're not using Kubernetes to manage your control plane components, then it's really hard to actually figure this stuff out. So that's something that has been discussed a lot, but nobody's actually sort of gotten everybody to agree and gotten that stuff together and made it easier to expose that type of stuff. It's one of those things that we want to be able to do with Sonaboy. All right, so let's get going. So I have a cheat sheet here that I'm going to pull up. So the first thing we're going to do is we're going to actually set a couple of environment variables. We're going to get the version, which we're downloading from here, which is sort of the latest thing here. So if I do actually just echo version, v180, so that's the latest version. So we go ahead and grab that, and we're saying we're doing this for AMD 64. And then we're going to go through and we're going to download kubeadmin directly, the latest version here. Now, the Heptio quick start that we do, we don't use the package, the Debian and the RPM versions of this. Now, if you read through the regular kubeadmin sort of install instructions, they generally will, and that's a good way to get these things, and it's definitely easier than going ahead and downloading them manually like this. Currently, the release process, a lot of times those debs and RPMs can lag for a little bit, and so we're downloading these things directly from the release buckets, the Kubernetes release tree. The other thing to keep in mind here is that if we don't want to upgrade the kubelet yet. So generally when you upgrade, you're going to upgrade the control plane components first, and then you're going to go ahead and upgrade the kubelets that are in your cluster. If I did an apt-get update kubeadmin, I believe the dependencies are set up such that will also update the kubelet at the same time. Or at least George, when he did this, said he had that happen. And I think he might be running on CentOS, so maybe that's with the RPMs. I don't know if the debs do the same thing. And so you want to be careful that you grab the latest kubeadmin without necessarily bringing your kubelet along for the ride yet, because you don't want to be doing those things out of order. So now I have a kubeadmin sitting here, and I'm going to go ahead and I'm going to install this into user bin kubeadmin. So install is like a command that does sort of a safe sort of rename type of thing and sets modes, and so it's easy way not to screw it up when you're installing binaries. And now I can do kubeadmin version, and we can see here we have the 1.8 version of kubeadmin. So that's good. And then the next thing I do here is I do sudo kubeadmin upgrade plan. And what it's going to do is going to say, oh, is your API server running? Are the nodes healthy? Checking to make sure that the static pod manifests are there. It can find those and make sure that everything's correct. And then it says, oh, like when you ran kubeadmin init, you gave it a bunch of options. I'm going to need to know those options when I do an upgrade also. So one of the things that we could have done as we designed the kube upgrade command is we could have made you re-enter all the options that you gave when you did a kubeadmin init. But that's going to be error prone and you're going to forget that stuff over time. You may have forgotten it already and you're going to have to sort of recreate some of that stuff. In the future, what we're going to be doing is when you do a kubeadmin init, it's also going to actually take the commands and write those things up as a config map into your cluster. And so that means that your cluster will know the commands that were used to birth that cluster, or at least the options used to birth that cluster. We didn't do that for 1.7, and so when you upgrade from 1.7 to 1.8, you have to sort of prime that pump and initialize that stuff. And it turns out that the options are a little bit tricky to get for what we used for the Heptio Quick Start, but it's easy enough for me to sort of recreate that stuff. So what we're going to do here is we have this file here, and this is part of the sort of bootstrappy stuff. Okay, so well, it's can't you update the manifest server file with the new version number and reload the service? So you could go ahead and you could do that, Wallet, but it turns out that some of the options and some of the features that change over time, we're going to want to go through and upgrade those also. And you're going to want to upgrade the controller manager and the scheduler also. And I think what we'll do is as we actually run the upgrade, you'll see, and we'll go through line by line, and you'll see some of the stuff that this thing is doing for you. Like, for example, we did the thing where when we authenticate nodes to the server, we're using a new group to actually rewrite the RBAC rules. And so we're upgrading those RBAC rules as part of the upgrade here. But over time, maybe it will be as easy as just rewriting that stuff. That'd be great. Okay, so what we can do here is we have this file, which is part of the sort of cloud init, CloudFormation init stuff that happens when we bring up the quick start cluster. And you can go ahead and you can look at this file. This essentially is the thing that runs kubeadmin for you, and then it applies things like Calico and the dashboard and registers it with a load balance. So there's all sorts of like fun stuff going on here. What we're going to do though is we need let's see. So we need these two lines here, and so what this says is here's my load balancer name, my external load balance name that I see. I accidentally named this cluster ingress and I meant to name it upgrade. And then here's the host name of the thing. And then it does this little thing here where it writes this stuff out into a temp file. And I'm going to copy temp kubeadmin. So if we look at this, it has the token in there. It probably shouldn't be in there as we do this, and so I'm leaking this to the world, so please don't screw up my cluster while I'm doing this. I'm going to take the cluster down afterwards. The only thing that's probably really going to matter here is the cloud provider for the upgrade, but it probably makes sense to keep all this stuff around regardless. And so then what we want to do, and if there's new options that you have to do the upgrade, they'll eventually be set in there, is that I can go through and I can do this kubeadmin from file, and then I have to do config equals kubeadmin.yaml. And so now this writes it into a config file in the kube system namespace. So I can do kube control get config maps namespace equals kube system, and there's the kubeadmin config, and you can see that that's there. It has one piece of data, which is essentially all of this. So now we can actually do the the plan. So this then goes through, and what it does is it says like, okay, so we got the config, so we got that, and then it says, okay, which versions can I upgrade to? And it says, well, the cluster version is 1.176, the kubeadmin version is 1.7.6, but we also can upgrade either to 1.8.0 or 1.7.8. So we can choose which of those we want to upgrade to. And then it actually breaks it down by the kubelet. So right now the kubelet is all at 176, but we can actually upgrade it to 178 if we're doing the 1.7 upgrade, or we can do a 1.8 upgrade, in which case here's all the components that are going to get installed as part of that. So we're going to do a 1.8 upgrade. And so now it's just sort of letting her rip, right? So I can do this. And this will go through and upgrade things. And it's like, okay, you sure you want to do this? And we're like, yes. And a couple of things that it's doing here is that it pre-pulls all the images, because what we want to do is when we restart the control plane, we want that to be as fast as possible. Now I'm running in AWS here. It has fast networking. It doesn't take that long to pull these. But if you're running someplace where the images took a long time to download and you just went ahead and did an upgrade without pre-pulling them, what you would find is that your control plane would be down for longer than you probably want it to be. So this is actually getting everything latent on disk. And then it's going through and let's see, it's upgrading the static pod. And so here's it's actually going through and doing essentially that upgrade that Wally was talking about, where it's rewriting these things into the manifest. And then it's moving those things into where it's at, and then it's backing up the old manifest. And so I haven't done this yet, but let's do a diff of the old manifest and the new manifest just to see what exactly is going on here. So, and then it goes through and okay, so yeah, we'll do that diff in a second here. And so it's upgrading the label selector and making sure that those come up okay, and then stores the configuration back into Cube System. And then it does a couple of RBAC tweaks because we're evolving sort of the security, and over time we're making things more secure. And this is the stuff that if you didn't do this, you might find that nodes weren't able to join. And then it's upgrading the add-ons, the DNS and the proxy as necessary also to the newest version. Those things are actually, the DNS is a regular old job because it's sort of a layer above the core Kubernetes control plane components. And then the proxy is a daemon set. And so those things are self-hosted in the truest sense. And I still have Slack running. Why do I still have Slack running? Go away, Slack. All right, so let's go through and let's actually compare. Let's do a diff of the old versus the new of these manifests. Kubernetes, and we have temp. Oh, wait, did it get saved? Wait. Whoa, did they get deleted? Don't delete them. All right, that's annoying. Okay, I thought those should be saved. So I'm gonna we should probably keep those around. I'm gonna take a note. Because that's a useful thing. So let's make sure that I'm not looking in the wrong place. Yeah, it looks like they got deleted. All right, I think those should probably have stayed around. That's kind of lame. Let's see, are they? Yeah, I don't see them anywhere. All right, let's do something a little bit. Sounds like a bug to me. Yeah, I would expect them to stay around. I'm gonna dig into that, and maybe that's something that we can fix for 181. Yeah, so let's go through and so it's in manifest. Is it somewhere else here? Let's search the whole thing and see if we can find it someplace else. See, look at that. I haven't done this before, and it leads me off the rails, and I find something surprising. So that sucks. Okay, but I will dig into that. That will be something that I'm going to look at, because I think you probably want to keep those things around just in case. Yeah, and I wanted to see how much actually changed. I mean, I can dig through the code to actually see it, but I think it would have been useful to actually be able to do those diffs. Okay, so now things are up and running again, and that was all pretty easy and painless. I can do now kube control version, and you can see that I'm using an old kube control on the client, but my thing is now 1.8, but I can do kube control get nodes, and you can see the nodes are still running 176. So now my control plane is upgraded, and we can actually go through and let's do get pods. If I can do this, and you can see that, say, the controller manager here is now running 1.8 also. So we're up and running, which is good. Found a bug, the manifest thing, or at least something that looks like a bug, so I'm going to dig into that. Now we have to go through and update the kubelet. So depending on how you installed and ran the kubelet, there might be a different thing that you need to do here. Typically, the kubelet is run by systemd. So we're going to go through and we're going to do the same thing here. We're going to download and install the kubelet just like we did the kubeadmin binary, and then we have to tell systemd to actually restart it. And so now we can do watch control get nodes as this thing actually restarts. And for about, you may find that it takes a second to be able to do it. And I believe as it does this, it actually goes ahead and restarts the pods there, which is, but everything soon comes back up and you're good to go. There's a lot of folks, when they upgrade their clusters, what they end up doing, if you're running in a cloud, you can do this. So Pat says, does it update etcd? Stop the pad. If so, what about the data? Or does it leave the pod running and not touch it? That's a good question. I don't think this version of kubeadmin upgrades etcd. I think it continues with the previous version of etcd. That's something that I'm going to have to look into. I don't think it touched etcd this time. The right way to do this would be a graceful shutdown of etcd and then an upgrade there. But etcd, is relatively stable in this world, and so this doesn't actually do an upgrade of etcd. But that's definitely something to dig into. As we move forward with newer versions of kubeadmin, upgrading etcd is definitely something that we're going to have to take into account. All right, so there we are. So now, we have the one node. Get nodes, yeah. We have one node running at 1.8. Now we have to do the other nodes, right? So I can go through and SSH into, say, this one here. Okay, Andres is saying, can you show how you would back up and restore etcd? I'm not prepped to do that right now. I think that's definitely something that we can look at. There's a question of backing up and restoring etcd versus backing up and restoring the contents of etcd. And I think that that's something that is worth exploring, and it's something that I think, here at Heptio, we've talked about doing a little bit of a blog post of what is different ways to actually back up your cluster. You can back up etcd at the block level. So that's one option. You can have etcd produce a dump and then use that dump as a backup to be able to reload the raw stuff in etcd. Or you can go through and back up the contents as they get filtered through the Kubernetes API server. And that's what we do with Arc. There's pros and cons to each of these things. A lot of times if you back up sort of the raw etcd behind Kubernetes back, when you try and restore it, there might be some things that don't line up, and it takes you some time to actually get that stuff figured out. Sometimes it works, sometimes there might be some problems. Currently, if you're doing a backup from sort of through the API server, there's no way to get a snapshot, sort of point-in-time snapshot. Usually that's not a problem, but it's something that currently is not supported. So I think that's probably a little bit of a different topic in terms of what are the ups and downs and ins and outs of backing up your cluster. I think there's also the question of okay, well, backing up, depending on what you want to do with that backup. Is it just, well, do I want to be able to restore this cluster, or do I want to recreate this cluster someplace else, maybe a disaster recovery type of thing? In the disaster recovery situation, you also want to pull out sort of persistent volumes and stuff like that, right? Because the state in your cluster is not always just the stuff that Kubernetes knows about. So let's see. So yeah, so some good discussions there. So yeah, so there's different aspects there. I think at some point it may make sense to maybe get some of the folks who have been working on Arc, Andy and Steve, to maybe do a little bit of a sort of whatchamacallit, a like sort of a guest TGIK to go over some of this stuff. That might be good. All right, so let's upgrade the other clusters here. Oh, I can't do it because like I don't like it doesn't know about me. It's like, oh wait, no, did it work? Look at that. Oh, ha. Oh, you know what? Okay, haha. So usually this won't work, being able to SSH from one to another. I think in this terminal, I'd actually sort of added this to my SSH agent in the past. So like if you want to do some of this stuff, SSH agent stuff comes into play. I'm not gonna go into the details of that, but as you sort of like want to hop around into situations like that, like this, that matters. So now I'm going to go through and I'll put this in a gist for folks. I'm going to go through and run all of this stuff here. And obviously, if you're using Puppet or Chef or Ansible, you can automate a lot of this stuff. But we're doing it the sort of hard way here. And we're going to and they're running 1.8 and they're going to be ready pretty darn soon. Yeah. So I think one of the things I was saying, and I think I might have interrupted myself there, is that some folks, there's like different sort of camps in terms of how do you upgrade a cluster. Some folks will do an in-place upgrade like this for their nodes. Other folks, and this is what GKE does, for example, is they'll actually provision new nodes and throw away the old nodes. Right, and so they really view nodes as disposable. And depending on, you know, whether you're running on-prem, whether you're using local disk in any way, you know, there's different decisions that make sense for you. It's generally like, as long as you're doing the upgrade, like you might want to also test and upgrade like the kernel that you're running on and the base OS and all sorts of different things. And so, you know, you really want to, as much as possible, view these nodes as sort of like, you know, disposable. Just because, you know, they will fail regardless. So you might as well use that to your advantage. If you're doing a rolling upgrade, you obviously want to do that in a sort of slow and responsible way. One of the sort of realizations as I sort of watched SREs deal with Borg inside of Google was that everything moved at a glacial pace, right? So you'd go and you'd want to upgrade stuff and you're like, all right, be done already. And you'd have a dashboard and you'd hit refresh and it would move so slowly. And the truth of the matter is that when you're dealing with stuff in these distributed environments in production, you want to move slow. You want to be careful. There's, you know, your human impatience is not compatible with high uptime. So something to think about as you start planning this stuff out. So yeah, so at this point we have an upgraded Kubernetes cluster. Now there's other components that come into play here. So again, you know, we were talking about in the chat etcd. There aren't any etcd updates, you know, with kubeadm this round, so that doesn't come into play. There's CNI, which is essentially the underlying networking infrastructure, common networking interface. So there's some CNI building blocks. We haven't upgraded those either. That's something that is, there is a new version out there, but I think most folks in Kubernetes have been using this one pin version and sort of it's a known quantity. And then the other thing is that like whatever sort of, you know, networking solution you're using may require tweaks also. And so in this case, we're using Calico, and there is a new version of Calico that we might want to look at upgrading to at some point, but that upgrade procedure is going to really differ depending on which provider you're actually going with. And then there's the underlying, you know, container runtime that you're using. All right, so Pat says, presume IP tables, DNS, etc. are available when kubeproxy and kubedns restart. Yeah. So the kube DNS stuff, you know, for larger clusters, folks will run a replicated, you know, set of kube DNS, and that'll work just fine. The proxy, generally, I believe, like cruises as it restarts because it generally just writes IP tables rules, so it's kind of out of the path, and you know, as long as things aren't changing, everything will be good. But all those components are built to sort of, you know, be restarted in clean ways and sort of clean up after themselves and make things good. So kube control is still missing the upgrade. Yeah, so we can do let's upgrade kube control here. We'll go through and I will sort of copy this stuff here, or these two things, and I'll do so now it turns out that the kube control that's sitting on your machines is kind of like, it's just a debug tool. So, you know, it's good to have the latest version there, but I think the common pattern is that you're going to be running kube control from your workstation for some other pod. So like here, if I do kube control version, you see I'm running 176 and 180. This is my laptop. I do brew update upgrade. Let's see, does that work? I don't know. I haven't done this before. Oh, look at that. So here I'm using the package manager on my laptop to be able to do that. And now if I do version, now we have 180, talking to 180. Kube control is a little bit forgiving when it comes to version skew. Generally things work pretty well, at least within a major version. And then Suresh says, updating the container runtime, for example, Docker would be challenging without affecting pods. Yeah, the backflips that like a container runtime needs to go through to be able to upgrade itself without impacting workloads because of the way that Linux works ends up being pretty painful. I believe that Docker split out the regular Docker daemon from containerd or as it did this stuff. So if we go through, and I'll go back here and I'll do here we have so it's containerd. So what happens is that you have dockerd running here, and then it talks to containerd, and then it talks to these shims, and these things are using runc, and so this allows this thing, and I think even this thing, to restart while these things actually all continue to run. And so over time, now Docker didn't used to be that way. It used to be that when you upgraded Docker, it would actually go through and restart all the workloads. But there's, you know, over time, there's been significant sort of work and backflips and re-architectures to be able to support that. While it says in 1.8 apps v1 beta 2, before I believe it was extensions v1 beta 1, this was with, after upgrading, what would happen to resources that had their API changed, such as daemon set, deployment, replica set, and stateful set, network policies? So this is not something that I think we do a great job of actually educating folks about. It's sort of like, there's sort of like, what is the parable of the shadows on the cave wall, right? What is reality and what is the projection? So I'm going to get, this is allegory of the cave. Yeah. So this is a Plato thing. And it comes down to what is reality, right? And it turns out that there's this idea that there's a true that we don't see. We just see shadows of what is really there. And it's the same way with Kubernetes and APIs, right? So these API versions are all reflections of a true thing. So they're all backed by the same store. And so that means that if you go ahead and you have old code that's operating with, say, extensions v1 beta 1 deployment, and then you go ahead and you have other code that's operating with the v1 beta 2, the app/v1 beta 2 deployment, those things will all actually be looking at the true thing. It'll just be different lenses that you're viewing that true resource at. So it's different projections of the true resource. Now, we don't have a good way, I believe. Actually, let's experiment a little bit here. If I do kube control get let's see. I don't know if there's a good way for me to do this. So let's look at the daemon set for deployment. All right, so if we look at, say, the Kubernetes dashboard deployment, I think, let's see, so Pat says, if you have a number of nodes, would it make sense to do the drain remove? Yeah, so you can go ahead and you can do that drain remove dance as you do this stuff. I probably should have done that. I probably should have actually showed how that works. You can coordinate and then uncoordinate. But in terms of sort of what is the true thing, we have a UID here. And this is an extensions v1 beta 1 deployment that I'm actually getting here when I do this stuff. The fact that this is still getting the extensions version is interesting. And then we have this UID. Now, is there a way in kube control get, can I actually specify? I don't know. I'm kind of a little bit in the weeds here. Let's see what we have here. All namespaces, include extended APIs, include on no headers, output, recursive selector, show kind. This is the kind. That's options for everything. Kube control help API versions. So this thing does support apps v1 beta 2. So can I do, I don't know, like what if I do, okay, so the resource type has to be, let's see if I can do, oh, can't have more than one slash. I don't know how I can actually say use this type when I'm doing a get so that we can actually force it. But and I should look this up because my guess here is, if I'm going to scroll up a lot here, sorry everybody. My guess here is that if you view the same object through two different APIs, they'll have the same UID, and so that's something that you can use to actually hook these things up and find it. Yeah, and so let's go through and we can I'm gonna explore. So there's also kube control. We also have some advanced commands where there's cordon and uncordon. And so what this does, and let's see, does the upgrade stuff actually talk about it? Upgrading. Okay, so this does kube control drain. Okay, so kube control drain. Okay, so the difference between drain and cordon. So cordon essentially says don't schedule new things on here. Drain says actually boot everything off this node, right, in a responsible way, making sure that I don't violate certain policies. Yeah, and so there's a lot of sort of detail here in terms of, oh, this is beautiful. And so then after a drain, you can put it back into service by uncordon. So you essentially drain and then you can go ahead and uncordon it. And there's a bunch of options in terms of how slow and deliberate do you want to be on this stuff. And so if you're doing any sort of upgrade where you don't want to yank the rug out from anything, what you can do is gracefully kick everything off of that node, shut the node down, replace it, that type of thing. And so that level of sort of coordination across the cluster is not something that there's sort of a single tool to do that yet. Generally, there's folks want to manage this stuff in a gazillion different ways. So yeah, so that is the TGI for today. I think we upgraded this cluster to 1.8, which is exciting. Any last questions before I go ahead and sign off? I gotta wait for the delay for you guys to be able to hear this. Yeah, so As always, I really appreciate everybody joining me. Spread the word if you thought this was useful, if you thought that there was something interesting here. Definitely let other people know. And I'm going to be trying to do this every week. And so also send me ideas. You can reach out on Twitter. And thank you for watching. I really, really appreciate it. And I will talk to you all later. Have a good weekend, everybody.